Welcome to clickmyproject.com. Let's discuss the project about a novel reversible watermarking technique based on adaptive thresholding and companding technique. In this paper, a new high-capacity reversible watermarking method based on adaptive thresholding and companding technique is introduced. It improves upon the fixed thresholding method by introducing block-based embedding and consequent optimization of the threshold for each block. In this way, the proposed method exploits the local block-based distribution of high-frequency contents, which allows embedding of significantly a larger payload for the same imperceptibility level than the FT scheme. Further, the proposed method does not require histogram modification to prevent underflow or overflow, unlike FT scheme. This is because the condition of overflow or underflow are being implicitly tackled in the iterative optimization of the block-based thresholding. Now let us see the view on the data flow diagram. First, we initialize T map to on M by B cross N by B 0 matrix, where B is the user-defined size of block and M and N are the height and width of the input image respectively. And the next step is, first we load our input image, divide the input image I into blocks of size B cross B, and then compute IWT for each block with the help of CDF filters with decomposition up to second level for obtaining middle and high frequency wavelet components, and then apply the compression function using the equation given in our base paper on all horizontal, vertical and diagonal subband coefficients that are less than T, and then embed the watermark in all subbands coefficients irrespective of T using the equation h dash equal to 2 cross h plus B, where h represents the original coefficients while B is the watermark bit to be embedded. Then compute the inverse IWT of block of I, G to obtain block dash of I, G, where I, J are row and column indices of a block respectively. In order to check that watermark embedding has not caused underflow or overflow, minimum and maximum values of watermark block are calculated and are checked in the formula given in our base paper. And then the PSNR of block star I, J is computed if it is embeddable. If PSNR is found to be greater than or equal to maximum allowed PSNR max, the threshold T is recorded in T map. Now increase the value of T by 1. This increment in T will increase the PSNR of the block after embedding the watermark. This is due to the fact that when T is small, more and more coefficients are compounded, and therefore overall embedding distortions will be small and good visual quality of marked image is achieved. The iteration will be continued till T equal to T min, at which point we obtain the matrix T map containing threshold value of each block of input image I depending upon the properties of that block. Now let us see the execution of the program. First we select adaptive thresholding companding embedding.m file and click run file. This is open dialog box. This is the image contained in our data set. We can select any one of this. Now I select this. Process is going on. Divide the input image I into block of size given by the user. Here we are using 8 cross 8 block size. Compute the 2D IWT to each block up to level 2, then obtain the threshold T from T map for the corresponding block and apply the compression function on the coefficients of each subband based on the thresholding T. Now embed the watermark W into block of ij using equation h dash equal to 2 cross h plus b, and then compute inverse IWT to get the watermarked block block dash of I, j. This is our watermarked block. This is our original bitmap length, and this is our compressed bitmap length. And then next step is extraction. Here extraction.m file is there, and then click run file. Extraction process is going. Compute 2D IWT of image I using serial filters and decompose the image up to level 2 to obtain HL2, LH2 and HH2 wavelet subbands. Using the unknown threshold value of T mean, extract the computed T map and block size information using the relationship B is equal to LSB of H dash. Uncompressed T-map related information to find T-map and block size. Initially B with block size information. Divide the watermarked image I dash into B cross B size block. Now compute the IWT of each block dash of I, j and perform decomposition up to level 1. Then we get the final result. And this is our extraction. Share actual payload and message bits actual are done, and the next step is performance analysis. Performance.m file and click run file. This is a fixed threshold value, and this is our proposed method. We have proposed a reversible watermarking system based on companding and adaptive thresholding. The proposed method has potential application in military, medical and law enforcement related image processing. By taking advantage of block-based watermarking and iterative optimization of threshold for companding, histogram pre- and post-processing have been avoided, which is usually required in number of reversible watermarking techniques reported in literature. The embedding and extraction process of proposed method are simple and computationally efficient. The method can easily be employed in real-time applications. Thank you.